Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through some of the questions from lesson 6 of continuous probability distributions. So shout out to Harvey. Thank you so much for giving me the idea to do this video. So lesson 6 is all about normal distributions. So normal distributions are always bell-shaped, and they always symmetrical, meaning the mean and the median are always equal. So the area above the mean is always 0.5, the area below the mean is 0.5. Now, when we calculate probabilities from a normal distribution, we're always interested in the z-score, which is how many standard deviations a score is above or below the mean. And that's what this formula here calculates. So in question 1, we're asked to calculate the z-score. So this says x follows a normal distribution. This first number is the mean. The second number is the variance. So the standard deviation is the square root of 36, which is 6. So using this formula, the z-score is score minus mean divided by standard deviation. So I actually get 2. That means a score of 82 is 2 standard deviations above the mean, which in this case was 70. So, question B. Here, this is a normal distribution, but the mean is 32. The variance is 100, so the standard deviation is 10. So, calculating the z-score, it's score minus mean divided by standard deviation. So here I get a score of negative 1.5, and that means this score is 1.5 standard deviations below the mean. So it turns out if the score comes from a normal distribution, then these z-scores will follow a special normal distribution called the standard normal distribution or the z distribution. Z is the special normal distribution with mean 0 and standard deviation and variance both equal to 1. So this is the general PDF of a normal distribution. Sigma is the standard deviation, mu is the mean. So in question 4, we're asked to give the PDF of the Z or standard normal distribution. So all we do is change sigma to 1 and change mean to 0. So the PDF of the standard normal distribution is just this. So standard normal distribution is basically the distribution of z-scores. All right, let's look now at some worded problems. So say the chest measurements of footballers normally distributed mean 95, standard deviation 8. So we want to find the percentage of footballers with measurements between 95 and 103. So note 95 is the mean. We were told that in the question. Now I'm going to convert 103 to a z-score. So score minus mean divided by standard deviation, I get 1. What that means is 103 is 1 standard deviation above the mean. So it turns out for any normal distribution, regardless of the mean and standard deviation, they always follow this pattern here. So you can see there are always 34.13% of scores between the mean and 1 standard deviation above the mean. So that will be the answer to part A. So part B. From a group of 200 footballers, how many would you expect between 87 and 111? So let's convert these to z-scores. So for 87, we go 87 minus 95 divided by 8 and get minus 1. 111 as a z-score, we go 111 minus 95 divided by 8 and we get 2. This is asking us how many we'd expect to be between 1 standard deviation below the mean and 2 standard deviations above the mean. Well, for any normal distribution, there are always 34.13 plus 13.59. There are always 81.85% of scores between 1 standard deviation below the mean and 2 standard deviations above. So the number we'd expect is just 81.85% of 200, and that's closest to 164. All right, find the value k such that approximately 16% of scores are below k. So we want to find k somewhere along here so that there's 16% of scores below. So note that these two numbers add to 15.87. So there's about 16% of scores in any normal distribution are below 1 standard deviation below the mean. And we already know that 1 standard deviation below the mean here is 87. All right, now we're going to look at a slightly harder question. So let's say time taken by Year 12 students to run 100 meters, normally distributed, 84% of scores are more than 12.5, 16% of scores are more than 13.9. We want to find the percentage that are between these two scores. Now, we can't possibly answer this question unless we know the mean and standard deviation. We first have to calculate those two things. So when we're finding two unknowns at once, you should think simultaneous equations. We're going to set up two equations to find two things at once, i.e. mean and standard deviation. So it says 84% of scores are above 12.5. Well, we know that 84% of scores are above one standard deviation below the mean. So 12.5 is one standard deviation below the mean. Now we know that 16% of students take more than 13.9. Well, 16% are above one standard deviation above the mean because these two add to about 16%. So what we have is 13.9 is one standard deviation above the mean. So our two equations are this. Mu minus standard deviation is 12.5 and mu plus standard deviation is 13.9. So to solve this simultaneously, what I can do is add or subtract the equations. If I subtract the equations, I'll get rid of mu. Mu minus mu is 0. I then have negative sigma minus sigma is negative 2 sigma. 12.5 minus 13.9 is negative 1.4. So sigma is just 0.7, and that means mu will be 13.2. So now, to find the percentage between these two scores, I'm going to convert them to z-scores. So 11.8 minus mean divided by standard deviation is negative 2. So that means 11.8 is here at 2 standard deviations below the mean. 14.6 minus mean divided by standard deviation is actually positive 2. So 14.6 is here. This question is really asking us what percentage of students are between 2 standard deviations below and 2 standard deviations above the mean. For any normal distribution, that percentage, adding up all these, is 95.44%. In any normal distribution, there are always 95.44% of scores within 2 standard deviations of the mean. All right, let's now look at some questions involving the graphics calculator. So let's try this question here. Suppose that the amount of petrol bought by customers at a station, normally distributed, mean 40, standard deviation 5. So what percentage of customers buy between 32.5 and 43 litres? So we can use our graphics calculator for this. So you press the second and vast button to bring up the distribution menu and pick normal CDF. That's what we always use to calculate the probability of being within a range of values for normally distributed data. So in normal CDF, you just input the lower limit, the upper limit, the mean, and the standard deviation, and it gives you the answer about 0.6589. So in B, we're going to convert these to z-scores. So 32.5 is 1.5 standard deviations below the mean. 43 is 0.6 standard deviations above the mean. So we need to use our graphics calculator here because the diagram we used in previous question only has information when it's a whole number of standard deviations. But here the z-scores are not whole numbers. So again, we input the lower value up to the higher value. Now, because we're using a z or standard normal distribution, z-scores have a mean of 0, standard deviation of 1. Turns out we get the same answer. And that's because it doesn't matter the mean and standard deviation in any normal distribution. The probability of being within 1.5 standard deviations below the mean and 0.6 standard deviations above the mean is this number here, about 0.66. Okay, so part CI is really easy. If you had 600 customers and the average amount they buy is 40 litres, you would expect to sell 600 times 40, which is 24,000 litres. So in this last part here, how many customers would we expect to buy more than 44 litres? First, we have to find the probability that a customer buys more than 44 litres. So once again, this will correspond to 0.8 standard deviations. It's not a whole number z-score, so we're going to need our graphics calculator. So we want to be more than 44 litres. So 44 is our lower limit. Now for the upper limit, normal distributions can always take any value. So we just need to put a really, really, really large number for our upper limit. So I just put 10 to the power of 99, which is about as big a number as you can put on the calculator. And then, of course, we put in mean and standard deviation. We get about 0.2119. So this score here is 0.8 standard deviations above the mean. In any normal distribution, there are about 21.19% of scores that are above 0.8 standard deviations above the mean. So how many customers would we expect? Well, we just multiply this 21.19% by 600. And we get about 127 customers. All right, let's look now at one more question. So let's say in my extremely smart methods class, time taken to complete a question, normally distributed, mean 5, standard deviation 48 seconds. We need the mean and standard deviation to be in the same units. So we're going to have standard deviation equals 0.8, 48 seconds equals 0.8 minutes. So if I select a student at random, calculate the probability they take under 4 minutes to complete. So again, I'm going to use my normal CDF function. Now here I don't have a lower value, so I'm going to put the lowest value my calculator can handle, which is -1 times 10 to the power of 99. So from there up to 4, and then we put in mean and standard deviation. So we get the probability 0.1056. So about 10.6 students will take under 4 minutes to complete. So question B is a bit tricky, because it says out of 29 students in the class, the probability that 5 or fewer students complete in under 4 minutes. This is actually discrete data. The number of students who can do something is obviously going to be a whole number. So it turns out if I let X be the number of students that can do this, complete in under 4 minutes, it actually follows a binomial distribution. Each of the 29 students is like a trial, and the probability they succeed and complete in under 4 minutes is 0.1056. So if I want to calculate the probability that X is fewer than or equal to 5, we need to use the binomial CDF function. So all you do is input in that the number of trials, the probability of success on each trial, which we just calculate, and the value of X. The binomial CDF function calculates the probability of being up to and including a certain value. So putting that on your calculator, we get about 0.92. So there's a 92% chance that the number of students who can complete this in under 4 minutes is 5 or fewer. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.